Thank you everybody for coming. Today we're going to be talking about tuning Tableau Server, tips from the performance SWAT team. So, just go ahead. Today the agenda of what we want to talk about, first we're going to start with some brief introductions. We're then going to talk about how to find performance issues. Then we're going to also move on to the critical next step of what do you do once you found them. And then we're going to have a couple conclusions and questions from the audience. So first with introductions.
Hi, I'm glad to be here. I'm Don McCready. I've been at Tableau for a little over 2 years. This is my third conference.
My name is Jonathan. I've been at Tableau for a little bit over 4, and this is my 5th conference. And we together have been running the performance SWAT team.
Right. So you might be asking, what's the performance SWAT team? Well, Tableau has a really competent supportability team that can field a lot of the kinds of performance questions that customers do have out in the field. I would say they can handle the lion's share of the reports that we get. Sometimes you need to escalate to the actual developers. So about 1.5 years ago, Jonathan and I founded the performance SWAT team, which is kind of a rotation of what I'll call the elite developers within Tableau that will actually handle the toughest cases that we run into or the customers run into.
Right. And now really quick, we want to learn a little bit about who's here and what your experience has been with Tableau. So as just an activity, please raise your hand and then we're going to go through questions, and as soon as one doesn't apply to you, just bring your hand down. So first question, do you use Tableau Server? Excellent. Very good to see. Have you ever experienced a performance problem in Tableau Server? More hands went up.
Jazz hands.
I didn't expect that. Did you work on it with support? Right. Have you spoken to either Don or myself on the phone while working a case? There are a few hands up. And then the last question, a select few. Have either of us visited you in your office?
Only Chris.
Yeah. You work in our office.
Hi.
All right, so yeah, moving along. So we want to start with how to tell if you have a performance issue. So this is going to be the first step and where we're going to get started. So the common symptoms, you're going to see the first one that I most hear when I get a report from customers, they're hearing it from their user base. So maybe a specific workbook is not functioning as fast as they want, or a specific project is underperforming.
You really get that feedback much quicker when those workbooks are the ones that the CEO looks at, for example.
Yes. And then also, another thing, we'll hear that the whole system might become sluggish, either at, say, the end of the quarter, end of month, or even during specific times of the day. You also may notice that there may be a group of workbooks that don't seem necessarily related. However, they all share a data source. That's another common pattern that we'll hear. Another symptom that you may see is processes on the server are restarting. So if you're looking at the system, you can see that, VizQL went down for a moment, or data engine, and then come back up. But that's a sign of something that we're going to look at.
And that could be due to a crash in the process, or a feature that we'll touch on in at least a couple slides called Server Resource Manager, which can periodically restart your server.
Mm-hmm. And then the last kind of feedback you usually get from your IT team or you yourself as an administrator may notice that your system is reporting heavy resource usage. So by this, we're talking about CPU and memory generally. You also may see network or disk utilization being quite high. So once you've seen these things, that's kind of the sign that we want to take a further look. So first, let's pinpoint on, so now we've maybe heard some of these descriptions. How do we pinpoint the performance issue? So to go on this, we're going to touch on a couple different tools, some of which you may have heard of and some which you maybe aren't as used to. And we should say that these start with kind of the most triage tool, starting at Task Manager, and we work our way down to more specific and more fine-grained analysis. So the first tool, which many of you are probably familiar with, is Task Manager. This is available on all Windows machines by default. It actually has been in circulation since 1996, so 20 years now. It's a really good standard. It's great, Control-Shift-Escape, it pops right up, and it gives you a snapshot of what's going on. So right here, I took a screenshot of myself starting Tableau Server on a computer. You can see that my cores are all occupied, and I've used roughly half my memory. So this is a really great first step. But unfortunately, I can't record this and share it with you in a great way, aside from screenshots. Another thing we could say is, well, what are the resources that are being used most by what process? So we can also move to this tab here where we can see on my machine, tableau.exe, again, starting up, putting some load on there. I sorted by memory. You can also sort by CPU. This is a good first step to see kind of what is the process within Tableau that is having an issue. Moving on, we have the next level of depth of recording is perfmon. And so this is another Windows utility that's provided. It should be available on all Windows machines. But unlike Task Manager, you can set it to record for as long as you want, or as short as you want. And there are literally hundreds of different system metrics. So it's not even just CPU utilization. It can be by process. It can be disk queue length. It can be memory utilization. It can be free bytes. There's really an endless limit. On this example here, the red line was my CPU usage, the blue line my free memory, and if you can see there's a little magenta line at the bottom, that was my disk queue. On my system, while doing a Tableau start, you can see right where the tab admin start was run. The nice thing here, you can record it, as I said. You can also set the sample length. If you're taking a short recording, take a sample once a second. If you want to have this running for days, set it to once a minute, once every 5 minutes, just to get a feel for what's going on. And the great thing is with these recordings, you can save them, send them to support with your logs while working a case. Moving on from that, we have, again, another more advanced tool called Tabmon. So just a couple of months ago, we released Tabmon as an open source project. And what it allows you to do is, first of all, you run perfmon on all of your boxes. So let's say you have Tableau server with several workers. Tabmon will actually reach into all of these boxes and record all of the perfmon data, store it locally on one machine. In addition, it's going to reach out and it's going to pull JMX data from Tableau. And also, you are able to then align, say, a resource utilization problem with activity on the server. Again, I mentioned that it is open source and provide the link for download. And these slides will be available later, so don't have to worry about getting the URL down.
And as Jonathan mentioned, it will sample events produced by the operating system, say for a Tableau process, and correlate it with the JMX counters that we ourselves are producing within our product.
And here's a quick snapshot. So once you've pulled all this data in Tabmon, it's actually stored in Postgres. It's in a separate Postgres than your Tableau instance, but it's the same format. And so you can connect to it with Tableau, and we ship it with workbooks like this that allow you to connect and see what system resources are being used by what process, what events were happening on the server, all in one viz. Because this will be very valuable when you want to say, what caused my CPU to go up? Maybe you had suddenly a spike in loads or some other behavior you're interested in.
So the performance recorder is a useful thing to diagnose the performance of individual workbooks. Many of you probably heard this, seen this before, but if you haven't, it's a really great way to get insight into how your workbooks are performing. It works on desktop and on server, and what you can do is it basically plugs into the instrumentation that our developers have put into the product itself. So at various points in our code, we have, okay, I'm starting an operation, I'm finishing an operation, and the output of this is just basically a CSV, and the CSV is then read by a great visual analysis tool called Tableau. And you can save that as a TWIBX, and indeed, if you ever engage support, probably one of the first things they'll ask you to do is save it as a TWIBX and give it to support so we can have a look at it. So this is a simple way it works on the desktop. You go to Help, Settings and Performance, and start the performance recording. And then you do whatever you are going to do that you are finding that is slow. That could be loading the workbook or doing some sort of interaction or some combination of both. And then when you're done, you say, go to the same menu item and you say stop. And it whirs, and produces a TWIBX file that will show you, for example, this kind of output. There's other tabs in this thing, but you can see by looking at this report that there's two operations here that are taking a long time. One is geocoding and one is executing executing a query. right? So if you're going to speed up a workbook, you're going to go for the slow parts and try and get them faster. So it's a good way to zero in on the, the thing to investigate next. And by the way, there will be a data kiosk in the expo hall. Tomorrow, me and some of my coworkers are there. We'd be happy to give you a demo of this.
So another thing that we want to enable all of you to do is do some log analysis. So traditionally, this might involve opening text files, looking for events, and that's not a very efficient or pleasant way to look at what's going on. So actually, just last Wednesday, we released another open source tool called LogShark. And LogShark is this very powerful tool that takes in your logs from a logs.zip, and it parses all of them, stores it, again, in a Postgres table, and we have a whole suite of vizzes for connecting to this. And we can, by using this, we can visualize when were different events happening, what was some of your resource utilization, like what's your backgrounder processes look like across different times of the day. And so these are questions that otherwise could be difficult to kind of all in one place quickly get the answer to, but now we have a unified tool that you can run and get the outputs of. And I'm going to show two quick examples. So the first one, we were looking at the Apache logs, which is also the gateway, as we call it in Tableau server. So right here, this is the results from one of our internal servers. Maybe some of you have heard of our server, we call it Alpo. And this was a 24-hour window of usage just about a week ago. And you can, in this viz, we had 45,000 views across the day approximately. On the left, we can see our most popular views. I obfuscated the workbook names, but we can see, one of our workbooks has 16,000 views in a single day. And when you're interested in a performance issue, we might say, do the performance recording on that workbook, because if you can start shaving 1-2 seconds off of a workbook loaded 16,000 times, think of the impact that'll have on your user base, both on the one-time experience of a user, but also the load on your server as a whole. And then also, with this workbook, there are many measures and dimensions, so you can color code, say, that scatter plot to see is there a pattern based on the worker that is handling the viz load, or any other sort of information. Again, from the same 24-hour period, we're looking at the backgrounder. So I had to hone in a little bit, mostly just on one worker's worth of backgrounders, because we have a lot of background events going on this server, about 16,000 in a day, sorry. So we like our extracts and our subscriptions. But here we can see a Gantt chart. When were events happening? How long did they take? Was there any crowding going on at certain times of day? And at the bottom, we see the average wait time for events to complete during any hour of the day. So that often we'll see spikes happening 8 a.m. or clustering around times that people prefer to set their extracts to occur. And this can give you insight on, do we need to have more backgrounders, maybe fewer? Do we need to move our subscription times or our extract refresh times to different parts of the day to allow for more performant experience?
So another source of performance issues on servers are process crashes. The thing to look for here are dump files. And the reason that, a crash and a dump file generated is a bug in Tableau, and we do like to fix these bugs. But for the most part, if they happen infrequently, it's not a huge source of concern. It will cause, maybe 1 or 2 viz loads to fail or something like that, or interactions to fail, but then the process will restart and everything will be just fine. But it actually takes time to crash. You have to generate these memory dumps, and you have to generate stack traces and stuff like that. And if it's happening frequently, it can be a source of performance issues. So note their frequency. If they're happening a lot, then it's probably we'll look at that crash and see if we know what's going on. The other reason that processes crash is that we have a feature in Tableau Server called the Server Resource Manager, and it's not so much of a crash as a controlled restart. Many of you may have seen this, but you can set up SRM, Server Resource Management, so that it monitors how much memory each VizQL process uses, and if it crosses a threshold, it'll kill the process. So it starts up in a clean slate and life is better. Same for CPU usage. If it detects sustained high CPU usage across the threshold, maybe it's in an infinite loop and it will kill that VizQL server process. So the key to look at there are log lines, because when the server resource manager does kill the process, it tries to tell, inform yourself and support that. You'll see that resource manager killed the process, and it'll give you the reason why. Sure.
This is a resource manager in Tableau.
Yeah, in fact, our services monitor themselves.
So how do we set it to kill the process?
But you can set it in the YAML files, so I forget the actual setting, but you can say, here's your memory limit. I want, if you cross 80% for, a significant amount of time, then kill the process.
More reading
More, I can't hear you.
or some literature I can click on that?
Yeah, I think you could probably do a Google search and find some good hits if you do Tableau Server Resource Manager. Mm-hmm.
All right. So now we've done the first step of identifying what process might be causing our performance issues, seeing what the problem is, but this isn't a useful thing unless we can do something about it. So that's where we're going to go next. So there's a number of knobs that we can turn, and we want to walk through those. So the first one being workbook design, like we talked about with very popular workbooks. This can be a huge win globally, or if you have an executive dashboard, it can be a big win locally with the users that really count. We can also look at database design, because at the end of the day, Tableau has to run queries. So we want to make sure that the database is as optimally set up to handle us as possible. We also can optimize extracts if that's the data source of your choice. We also can start to look at your Tableau topology, and by this I mean how many workers do you have, how are your processes spread across these. We also can look at VM resource allocation. So most enterprise users that I've encountered are on VMware, and so we want to have the optimal settings there for performance and speed. We also want to talk a little bit about if you have antivirus on your system. We also want to talk about opening up some ephemeral ports on Windows Server. And the last thing we're going to talk about is sometimes getting a little bit more horsepower. All right. So workbook design. Here, there are a couple small tips that we're going to touch on here as kind of a first pass if somebody comes to you with a workbook that is underperforming. The first thing you want to do is reduce the total number of filters in your view. And the reason for this is when you do an action and you have to end up doing a query, we have to take into account all of your filters and the values that you have set on them. And this can result in a more complex query that takes longer to run on the database side. Another thing we want to consider, kind of the next two go together, is how many marks can you functionally use? And also you don't want to have very large crosstabs. So if you have millions upon millions of marks, say in a scatter plot, that can be hard to analyze, but Tableau has to render all of them and compute their locations. And then with the crosstabs, a really great example I saw recently was a crosstab that was being generated where there were several filters all set to all, and it was approximately 5 columns and 8 million rows. So first of all, very tiny scroll bar, but this is 40 million entries. And if you think about it, each entry in a crosstab is like a one-word piece of data that you can comprehend. So that's 40 million words of information. The Lord of the Rings trilogy is 450,000 words. This is 40 million. And you just aren't going to analyze all that data at once, so you want to think, how can I make it that when I make the viz render that first time, I'm rendering the data I want to use and will be effective right away, not have it show all at the beginning, and you have to spend all this time rendering and querying. Another thing we want to consider is how many views are in each dashboard, because as you open a dashboard, we have to render each view, and each of those views has all of the previous things listed above. And if you want to learn more about this, there's a really great white paper that was written by one of our coworkers called Designing Efficient Workbooks. I provided the link to it here. This goes into depth on all sorts of different topics, and also there's a talk on that, which I'll be mentioning later.
So, and this talk is about tuning Tableau Server, and this slide is about individual workbooks. So it's important to actually consider, just like Jonathan showed on a previous slide, that by tuning an individual workbook, you can improve the performance of the entire server. That 16,000 view workbook. If you shave a few seconds off of that one, it'll make users of that workbook faster, but it'll make users of other workbooks unrelated to that faster because less of your server is dealing with this really slow workbook.
All right.
Oh, yes.
Is there an easy way to find out how many views you have in your dashboard, or how many marks is there, like a tab command or something I can run
So if you download it into desktop, there's information on the bottom bar. And actually, the talk before this one, unfortunately, it was in this room right before now, was about a tool that was released called Scout, which goes through and pulls metadata from all sorts of vizzes on your workbook. So, and all the talks were recorded, so you can go back and watch that.
Or Auditor would be the other tool that would tell you information about the workbook itself. Okay?
All right. So the next thing we want to touch on is database design with respect to Tableau. So the first thing to consider is fewer columns are better. So there's two reasons for this. The first one is when you connect your data source, Tableau has to make connections and metadata calls for each column. And the second one is no matter how many rows you return, we need the entire row. So ideally, if you're going to have a database that's highly used, we want to have it be the correct number of columns for all the measures and dimensions that you use in the workbook, but kind of shave off that excess so that the amount of data being sent back and forth is reduced. Another thing, we can index on any key dimensions that live in that database. So again, going back to the filters comment, you want to have these indices be along all of the dimensions that you're filtering on, and you don't want to have too many filters, as too many indices will grow the amount of information at the end of the day.
Does that really only apply when it's a line connection, though, to the data?
Oh, as opposed to once it's extracted?
Yes.
Once it's extracted, there's separate things to do, so yeah. If you do an extract once and then use the extract, you don't need to worry about that as much.
There's a question in the back.
Oh,
So when the have to make the database, they say for the first time, right?
mm-hmm.
Does the metadata rate, is that actually the of the normal or is that not factor to read the structure of the data?
Are you saying in the data window of desktop?
Like on desktop, you get to the
I believe,
it has to read the metadata layer of that particular table.
mhm.
So most of the time when you're hitting on a high table, it takes enormous time to read the metadata. So the reason what we figure out is might be reading a lot of millions of rows or to just actually read the top 10 just to make sure it has the right column, right data type fine. So I would like to explore more on that, like why it has to go to each row rather than check only one or two row and make sure the definition of the table is correct.
Right.
I would like to comment on that.
That's not something that I've looked at in particular, but that is also a separate team. Yeah. Mhm.
Yeah. So, yeah, if you see Tableau doing something that is, inefficient as a query, I mean, we have a query team that is, very interested in generating the best queries. So just, bring that up, and we can send that to our query team. So you can get the performance recording that I talked about, and when you click on the query elements, it'll actually show you the query that's generated, and then you can share that with database people. We'll have a slide on that very quickly as well. Mm-hmm. Mm-hmm.
So with LogShark, one of the features is that you can go and you can look for all of the events. They're going to be called end query. That's where we record both the number of rows returned, but also the query execution time. So at first you can use that page that showed the kind of viz load time. Selecting that, you can go based on that session into the vizql logs, and from there you can actually see the length that a query took and how many rows were returned. And so then you can use that, say, for your discussion then with that user at that point. One other thing, as was asked earlier, is what happens if we move into an extract. So we recommend if you have a very popular workbook, rather than having a live connection, where you're doing a query many times, it's going to a remote system, get an extract, get it local. You can publish it and share it across many workbooks. So this is a kind of quick win you can do. And then also when you have that extract, you can optimize it. So two really great things to do there are hide unused column or hide unused fields. And that essentially does the pruning of columns like I was talking about, but at the data engine level. And then the other thing is that you can do a data source filter at extract time. So the easiest example to think of is, let's say you have 2 decades worth of sales data for your company. And you know that in this viz, we're only really interested in year over year for the last 5 years for some reporting metric. You can have your extract only contain that last 5 years worth of data, and there's less information to query, and you did hide unused fields on all those fields that weren't necessary for your viz, and you're going to be improving your performance right out of the gate there.
Yeah, so for for the more advanced user, it's very good to get to know your friendly neighborhood DBA. Most enterprise level databases have a query analyzer of some sort. And what these things do is basically monitor all the queries coming against the database and show you their query plans. Tableau tries to generate the very best queries so that the query plans are fast. But even a relatively moderately intelligent end user can probably spot when a table scan is happening in a query over 1 million or 1 billion rows. That's going to be a red flag, and that's when you can employ materialized tables or add appropriate indexes. If your queries are still a little bit slow, your DBA is an expert at this, right? And he'll be an expert at this tool, and he'll be able to tell you, that there's other things going on with your system, maybe query related or maybe IO related. It'll all show up in the query analyzer. So if queries are your problem, get to know your local DBA and sit down with the query analyzer with them.
So moving on, we briefly want to touch on Tableau topology. This can be a very big field and is very specific to different use cases. So we're just going to give a couple of our kind of top pieces of advice that we give. And the first one is, if you find that you have backgrounders that are busy refreshing extracts or sending subscriptions during your peak usage time. So again, you could go back and use LogShark to see when are your backgrounders running the most, when are your users using the product the most. You might want to look at isolating the backgrounders onto their own machine. The reason for this is you don't want to have them running, using up CPU, while then you have users coming and waiting for vizzes, and their wait time is experienced in real time while they're in the browser. So separating that has always been a big win. And also, if possible, you can take those background jobs, and if it makes sense, have them extract late at night. 2 in the morning is a very popular time for extracts, but not necessarily for employees to be in the office. Another thing, there's a specific ratio for processor to VizQLs that we suggest, and you kind of want to have about 4 CPUs available for each VizQL server process that you're putting on a box. And part of the reason for this is VizQL server, it's that engine that's going to be processing, making your vizzes, computing layouts, drawing the vizzes. It can run in parallel, it can use a lot of resources, and you want to give it breathing room so that your users get the best experience. Another thing we like to see, a lot of people add many cache servers, and actually with Tableau Server, you can have a much smaller number of cache servers, one a box, where it's enough. It can handle all of the queries that's coming to it, but we're reducing the amount of crosstalk between processes. And this crosstalk actually comes up for the next discussion, which is Zookeeper. Zookeeper is a process that is a third-party tool that is integrated into Tableau, which helps communicate between all processes to see what is available. So in case you have an outage on a machine or a process did a crash like we were talking about earlier, we don't want to try to send user requests to a VizQL process that's in the middle of restarting. But with Zookeeper, the more of them you have, the more crosstalk you have, the more network traffic you end up having. We recommend keeping about 3 to 5, and usually 1 on the primary, and then the other 2 distributed elsewhere, but is not, aside from the 1 on the primary, there's no stickiness to where it's better suited than others.
Yeah, and it's good to have a odd number because Zookeeper votes, and so having an even number introduces the risk of having no solution to the voting outcome. And the other thing is to bear in mind is some of the world's biggest websites run with no more than 5. So, I mean, 3 is probably fine for you. Oh,
Question on the background.
okay.
And I using the before installation. It looks like the background take over two core.
Over 2 cores.
Yeah. So what's the difference between moving the background to a total system and also in the same system?
If you have backgrounders running in the same system as VizQL server, then they're all competing for resources, and all the operations are going to get a little bit longer because they're all going to be preempted.
So even they have a separate core, because I look at them, looks like the VZ also is separate in another core.
Oh, but there's no core affinity between the processes. All the processes believe they have all the cores available. So when they're on the same box, there's no affinitization of processes with cores. Each one of them independently believes, and this is true for almost every software out there, they independently believe they own all the cores. And they use the operating system itself to time slice between them. So you get a little quantum of 50 milliseconds to VizQL server, you time out, goes to backgrounder. 50 milliseconds, time out, go back to VizQL server in a fair, round-robin way. You're welcome.
So the next topic we want to talk about, which also touches a little bit about that, is VM resource reservation. So when you're allocating VMs for Tableau, we want to keep in mind that Tableau is compute heavy. Like we're saying, we run queries, we compute layouts, we compute rendering, we send images, we send subscriptions, we're refreshing data sources. All of this is compute heavy, and also you want to consider that for some of those events, you have a real user waiting in real time when they're loading a viz. And so we want to keep that performance as snappy as possible. And for that reason, we recommend doing resource reservation on CPU and memory. So VMware has actually produced a really great white paper with the link here that is talking about latency-sensitive applications. And in their white paper, they're saying that you want to actually allocate 100% CPU and memory for these applications to keep that performance snappy so that your users aren't experiencing additional lag when you're waiting for, say, CPU or memory to be allocated for your VM to take action. And a quick note, we just want to touch on that with 100% reservation means that Tableau would get first crack at the CPU allocated to it, but not, say, at an off hour when no one is using the server, other VMs can come in and use those resources. So you're not blocking it off forever, but that when your user is there and they're waiting, they get the resources then and they don't have to wait. And so actually the next slide I'm going to show is we did some testing internally at Tableau, and I want to describe the test before I show the results. We took a VMware host and we put 2 VMs on it. One of the VMs, we ran a number of hardware tests to use up CPU and memory. And then on the other VM, we put Tableau server. And then we decided, let's run some load tests on this and see how it performs. And we started with no reservation, and the two VMs competed for resources in an unreserved environment. And then we slowly started cranking up the reservation on the Tableau server. And we want to see, how does our transactions per unit time change? So on the graph I'm about to show, we start at 0, and we work our way up to 100% reservation. And so you can see when we had a full reservation, we had full throughput. But as you scan all the way back down to the left to the 0% reservation, we were only able to handle about 34% of the load. So this is a pretty big difference. And that's going to be experienced by your users. And this, the transactions here that we're looking at were viz loads. So this is something to consider when you're looking at reservation. The nice thing to see is at about 50% reservation, you get 87% of the throughput, which is pretty good. And if you just bump up to to 60%, you get 97%, which is very close to 100 and very nice, but you didn't need to go for the full CPU reservation. So the VMware recommendation is for 100%, just to give you the full amount. But you can do partial if you have limitations on your system. So we also want to now shift gears a little bit and briefly touch on antivirus. So many of you work for companies, and companies have policies. So again, Tableau is latency sensitive, and antivirus software can influence how quickly Tableau can perform a certain action, not even necessarily competing for CPU, but that, say in the next example, we have security software can act as a filter driver. We don't want to have Tableau having to wait for additional checks to happen before it can do some of its actions. So one of the things you want to do is, if you have active scanning, you want to have Tableau and Windows directories exempt from the scanning. This way, as Tableau needs specific system DLL calls, we're not going to be waiting for approval from the operating system each time. And then one other thing, if you do have to run a full system scan, we do recommend that you schedule this for some sort of off-hour time. Again, my example of 2 in the morning, a popular time for background jobs, but not a popular time for people to be in the office. Example of a really good time. And that helps free up performance, and it's always a great step.
And we've seen too many instances of this. I mentioned the server resource manager. It monitors itself by making some fairly low-level kernel calls that security software actually finds suspicious, so they intercept them and then they do additional checks. And if this is happening, an operation that should take literally 2 or 3 milliseconds can then take seconds, as it does checksums on the DLLs that it's using, and it can really, really detrimentally affect performance. And there seems to be a fairly simple workaround for most of these issues, just by excluding Tableau from the scans.
Oh,
Yes?
On the exclusion list, Tableau on down, right? Directory runner.
yes.
And then what is it for Windows?
Windows on down. C: Windows on down. Yeah.
So the next topic we want to talk about is your ephemeral ports for your network. So Tableau, especially once you have multiple nodes, all the processes talk to each other. So for example, when we were talking about cache servers, cache is not necessarily localized on a box, and a VizQL server on worker 1 can talk to a cache server on worker 2, and vice versa, and all these processes are talking, and they need network ports to do it. The default Windows Server ports are about 49,000 to about 59,000. However, we can expand this, and that actually allows Tableau to have more breathing room along with any other applications that are running on the system. So it's made a big difference before, where you can actually basically double the number of ephemeral ports. You can go down to about 35,000, and then have that whole range open and available. We have an article, so this is a thing we've recommended often. So we have a knowledge base article that walks through every step of doing it. And this configuration has vastly improved performance. And
Yeah,
I'll give an
and we
example
had
of
a performance SWAT case where that was true. A customer had a 24-core server, and they were running into this port issue, so they were not able to have the throughput that they really wanted. To get them over the hump, because they were approaching the end of the month, they actually commissioned a server that had 3 times as many cores. We're renting it from IBM, and they actually used that to get over the quarter. But we were able to diagnose down to this issue with a fairly simple netsh command to fix their issue, and we were able to show them that they could totally support their load on their 24-core server without having to buy a bunch of new cores.
Sorry?
I hope we open all the ports, but we any other ports we open, but they've been getting some logs.
So to do that, you use, as Don was saying, you can use the netsh at the Windows level. You can do the command dumps for all your ports. You don't query for each individual. It gives you the port ranges that are set. And then you modify the lower end. The setting, I believe, you say, I want my lower end to be X, and I would like to have the Y number of ports above it open. And so in our case, you'll say, starting at 35,000, please open the 30,000 above it. Rough estimates on the numbers. Yes?
Recommendation on the ports, are you saying that you should start with that, or that you would do that after you found out you had some issue and you traced it to be a port problem that you discussed?
I would recommend it only if you're seeing this issue. If it's working out of the box with the default port settings, then there's no need to change it.
And we should say that you have to do it on each of the boxes. So it's not, because it's a Windows setting, not a Tableau setting, we can't percolate it for you to the other boxes. And you do need admin rights to make the change. And so the final topic we do want to talk about is getting more horsepower. So we've tried a number of things. We've tried settings. We've changed things in the operating system. We've optimized the VM. Sometimes you need a little bit more. There's always a limitation. So one type of issue we will see is that memory is the limiting factor. And the nice thing with memory is that it is easier to add memory than CPU. So that is a recommendation we can make if you are kind of closer to the min-spec side on memory, you can add some hardware, and that's going to make a difference. We understand CPUs aren't quite as easy to add on the same box, but you may have to look at increasing, especially the thing to consider is if your performance is tied to peak usage. So an example, during the workday, or I had one customer where at the end of the month they had 3 times the usage in a day of any other day in the month because they had internal and external sales information that they had to share with their coworkers as well as their shareholders. And so they had to make a decision, and it's a discussion that you need to have about, do we want to accept that? Do we need to scope our hardware to meet that peak performance? Or do we just understand that there is a narrow band of time where you may have kind of slower performance and a little bit of queuing?
Yeah. And on the performance SWAT team, we are definitely biased to getting the performance to an acceptable level given the system you already have. As I mentioned in the last case, we were able to prevent the customer from going to 72 cores when 24 cores would been just fine. We like selling people cores, but we like it to be for good reasons. Sometimes you are going to exhaust the capacity of your core count, and just going to have to buy more. But we will definitely go through all the rest of the steps for you before coming to that.
So we have a couple related sessions that we recommend people go and see. Unfortunately, due to timing, the first 2 have occurred, and one is concurrent to us now. But again, all these sessions have been recorded, and you can go back and watch them. So the first one is a dedicated talk about LogShark, which is by my teammates, so I highly encourage it. And they're going to be giving examples and diving into how you can use those vizzes and make your own based on your data. There's going to be a talk, Designing Efficient Workbooks, live on stage, which is based on that white paper that I referenced, and the author of that white paper is giving the talk. So that's going to be really good if you're interested in diving more into that aspect to help your users. On Thursday, though, we're going to have Improving Server View Performance by another one of the devs on our team. And then, as Don mentioned earlier, with regards to the performance recording, there's going to be a data session at the data kiosk from 1:30 to 5:30 on Wednesday down in the expo hall.
See you there.
Yeah. And please don't forget, complete the survey in your TC app. And we'll stick around and take questions as we have time allowed. So,
Thank you.
thank you. So, we'll start going around. Yeah?
What are your thoughts on somewhere in the middle between redundancy and isolation, where you have a machine, where you have a base install on both workers in a 3-node cluster, but one of them is more of a backgrounder specialist with 4 things, and one of them is a visual specialist with 4 or 6, but they each have a little bit of everything? Or do you truly recommend, and think of one of them failing? I have a failing
Right.
functionality. So what are your thoughts on that?
So my concern is, oh yes, I will repeat the question. Thank you, Chuck. So the question had to do with if you have a environment where you want to have redundancy, but so is it better to have redundancy where you have a box with both background and VizQL on both versus just having a dedicated background or dedicated VizQL? Is that, I'm like, okay. My personal thought is you're going to run into issues where Tableau is going to be round robining to the different VizQL servers as requests come in. And then the backgrounders, assuming they're busy during the day, are going to fight with the VizQL, and they're all going to want CPU at the same time. So there's a performance risk there. If you know and can control when your really heavy background jobs happen, say, everything can be updated at midnight, then it's safer if there aren't many events happening during the day. What are your thoughts on that?
I think you could maybe dial it up or down depending on your needs. So if you started with them totally isolated, and maybe you could move 2 over, you get a little bit and only a little bit of impact. But if you put too many, the impact is going to be higher and higher. So you just have to measure, I guess.
Yeah.
And so a couple of years ago at a conference, I remember that similar session you guys were talking about NUMA nodes and basically parallel memory access to the data engine. We were on virtual machines at the time, so I didn't really bother with it. We're not on physical servers. Are there some settings that you can do to basically double the memory bandwidth to your data engine on where you have servers where you have that installed? Or does it just naturally use that?
I don't believe the data engine is NUMA aware. If you heard about Hyper this morning, Hyper is very NUMA aware, and I guess it will be interesting for all of us to learn about the best settings for the Hyper data engine.
3 years ago, they said that it was aware. I mean, it was in a session just like this.
Well, it has a degree of parallelism setting that you can set on data engine, and you know, you probably shouldn't set it to the number of cores on the machine. 4 is usually, I think that's the default, and it's usually just fine. And of course, you can have multiple data engines, and they each will have 4, and try not to oversubscribe each other. Normally, the operating system itself is pretty good about isolating things within a NUMA node to keep things in the cache. If they're start spread out, they'll eventually migrate so that they'll use threads on a NUMA.
Common thing to dig into. I shouldn't waste a lot of effort on it.
No, I wouldn't waste a lot of effort on it. There's probably a lot low-hanging fruit than that.
Are there other questions?
There's one in the back there.
Oh,
How do you actually engage your SWAT team? Like, does it go through support, your account manager? How does that?
Yeah, the question is, how do you engage the SWAT team?
yeah, so the SWAT team is reached through support. So if you have an account manager, that's one way, or if you filed a ticket, and what will happen is the support team is going to try to work your ticket initially. So I work with the support team very closely, and I provide them documentation about investigations I've done in the past, settings we like to recommend, so that they can be more responsive. And then as Don was talking about earlier, they're going to be very good, handle most of those perf cases, but then once they start getting into head scratcher territory and need that boost, they're going to reach out. We have a kind of a system to get support cases into dev, and we're right on the other side of that bridge in dev, getting information from them, and then we'll work with the developers in the related field to where your issue is.
So no direct line, direct to SWAT.
I will not put my cell phone number on the screen.
Batman symbol or something?
If I see it on my window at my desk, I'll call. Yes.
Guidance on cache servers, either in terms of the number of them or the size of them. And today I saw you said something about a small number, whatever that means.
Mm-hmm.
But I haven't seen anything else on the site that speaks to trying to size those or the number of them.
I think the default is 2 per worker, and the default memory is, I forget, 512 gig. I think that's a very good number, because if you have too many of them, as Jonathan started talking about, there's crosstalk, and that's a lot of memory. And so you don't need too many of them. And the reason that I don't recommend 1 is that the cache servers are single-threaded. So if you have multiple VizQL servers trying to hit the cache server, they might get serialized behind the cache server. So that's why I recommend 2. But beyond 2 per worker, I think that's probably plenty. You probably don't need more than that.
The number of cores or memory?
Yeah, regardless of the number of cores or memory. So you can actually, the cache servers, you have to do some log spelunking to know, unfortunately, to know whether you're hitting or missing. So, but you can do that. And if you see that you're missing the cache a lot, then you can, I would first try bumping the memory up, like make it, a gig. I mean, whatever, twice as big. I would do that before adding more, right? Because memory is generally cheaper than cores.
Yes?
I have a question around the search and browse process.
Mhm.
Is there like a max number of search and browse processes that can run in the cluster? Asking because we had a case where a search and browse process just kept going down,
Mhm.
and no matter what we did, even increasing memory and things of that nature on our server cluster, and it only went down on 1 worker, right? Because all the other search and browsers were just fine. But on 1 worker in our cluster, it just kept going down. So I was wondering if there's like some type of a unknown max or something for search and browse.
So really briefly, the question was about the max number of search and browse processes that you could have on your server. It sounds like you were about to chime in.
Yeah, not that I'm aware of.
Yeah, but you could add more, and I don't know of a limit. Hmm?
Checkbox, you can have only 1 per worker.
Yeah. So I guess, yeah, you're not.
If it's only happening on,
The cluster, like I was just wondering if there was a max for cluster.
I mean, you wouldn't.
You're not aware.
I'm not aware of
Yeah.
it, but if it's only happening on one worker, I guess it's time to pull out LogShark, right, and look for these restarts. I mean, there could be the server resource manager might be restarting these things, or Zookeeper might be restarting them.
Yep.
My question is like, let's say in a cluster, right, we actually isolated the background of a particular worker node.
Mhm.
And in that we have like more than like 6 to 8 backgrounders running there. So most of the time we get like one of those goes down in status monitor. And whenever we try to figure out what exactly we need to do, it's very difficult. Because it has the code record instance name on that, but if you go to the task manager, all the backgrounders has process ID. So that process ID doesn't sync with what you see on status monitor.
Oh,
You guys started that one with someone for that.
so in that scenario, I believe you can use Windows Procmon, and it has port information for processes. And so if you, as you said, you know the port number of the one that is down, you can do the correlation there and also do the termination of the process. Sorry?
It's not a straightforward, like easy way where I can just go there and kill it from there. There is no way I can figure out like I end up with serial killing one at a time, which I can't do with the production.
Right.
So most of the time we try to take over all the CPU and memory, and we are in a hurry to find out which is the background of trying to take all these resources. And it's always a challenge for us to figure out which one is supposed to be.
Yeah, so I don't know of a way like from the admin page, you know, there's no functionality on the admin page to select a process and say, restart this.
Yeah,
Yeah,
consider it a feature request.
Yeah, we know who to get it to. Thank you. Are there any, oh, yes, right up front. Oh, wait. Oh, we had two in line.
We have an 8-core box in the server admin. We're very subscription and extract heavy, and we're still relying on the 2 backgrounders.
Yeah.
They finish at about 10 hours, and all of our usage is like a 9 to 5 standard workday.
Right.
If I add a third process, is it just essentially running 3 at once instead of 2 at once?
Yeah, so there is a little bit of serialization if you do a lot of subscriptions of the same workbook. But if you have just everyone's choosing their own subscriptions, you have extracts running, which I'm assuming is generally what you have. In that case, all 3 will run together, and say if you had 2 running for 10 hours, now you're going to have 3 running for 7 hours. Or it will shrink it down in that way.
They are in the same schedule. They will run serialized, right? They will run parallel.
Yeah, they will run in
They will run in parallel if they're separate processes.
Because they were not running that online that we are not going to change it. And I actually read tickets with the support, and they were saying that background run in parallel, but subscription don't.
So if you have many subscriptions of the same workbook, those will be serialized? Yeah. So, so you're saying you had like 10 different workbooks? Mhm. There is a setting, and unfortunately I don't remember it off the top of my head, but there is a setting that you set with tab admin, and but it is something along the name of subscription parallelization, and it's a Boolean, and so you can tweak that starting in, as you're saying, in 9.2. So you can, there's the default behavior, but you should be able to disable it and go back to the always parallel all the time. But you do lose a little bit of caching. That was the initial rationale for having the serialization. But if you want the parallelization, you can do that. Yeah.
I don't think there's a correlation in caches. I think the recommendation for cache servers is still stands. 2 is fine per worker. I'm not sure about data engine. I think you
Oh, you're saying if the VizQL, say, on one of the non-backgrounder workers needs that data engine?
Like if I had two data engines on my
5 minutes.
primary worker, you know, I got two other dedicated servers just for backgrounders. Like, I know the data engine on the backgrounders is causing any issues with my user.
I think it would cause more issues with the backgrounders, right? I think it would actually be a good choice to put it on the backgrounder machine, right? Because as Jonathan said, okay, if your refresh takes, 6 minutes instead of 5, nobody's going to notice that. Whereas if it takes a minute more to load a workbook, people are going to notice that in real time.
Yeah. By the way, we got the warning of 5 minutes. Let's take probably one more question, and then we can move our way into the hallway. Maybe 2 if they're quick. Yes.
Since Tableau is so heavily in visualization, have you guys looked into using a better video card for help the performance?
We have looked at parallelizing things on video cards using CUDA and technologies like that. Doing that, I do have some experience in this. Doing that kind of requires a re-architecture and a rethinking. You need to lay your data out in different ways so that it's actually more performant on a GPU. And the problem with GPUs is they're a very scarce resource. You can do some time slicing on a GPU, but for the most part, there's going to be one operation handling on the GPU. You have to copy your data to there, do the operation, copy it back. If there's high load, like thousands of people using your server all at once, they are not going to be able to benefit from the GPU because the GPU is such a scarce resource.
All right. Yes.
What's your recommended ratio for the number of backgrounder processes per core?
I believe it's
One.
one for
One for one.
one for every one. Yeah.
Yeah. So 8 core box, 8 backgrounders. All right.
All right.
Thank you,
We'll
everyone, for
hang
coming.
around outside if you have any other questions. Thank you.